Humankind's been producing chlorinated solvents for decades on an extraordinary scale. The properties that make them so useful are the same properties that cause enormous trouble when they're released into the environment due to improper handling and disposal. As an example, at the Botany Industrial Park not far from the University of New South Wales, we have a legacy of industrial usage stretching back to the 1940s, 1950s, where a lot of chloroform and dichloroethane has been spilt into the groundwater, and that's all still there. It dissolves slowly, as creating a plume that moves off-site and ultimately threatens Botany Bay. The site custodians on the Botany Industrial Park have installed a groundwater treatment plant. The plant cost around $167 million to install. It's very energy intensive to run, costs the site custodians a fortune to maintain. And they're going to have to do that for around 200 or 300 years. Our solution is a natural one. We develop microbial cultures for inoculation of the groundwater to clean up using a natural mechanism so the bacteria break down these pollutants. We take samples from the contaminated environment, which contain billions of different bacteria, and we bring them back to the lab and we incubate them under specific conditions that favour the organisms that can actually break down these compounds. We then grow them in beer kegs, so to scale up to get a few hundred litres to inject into the aquifer, and then we truck that to site and inject under nitrogen pressure into the aquifer. The bacteria has come from that environment in the first place, and it colonises the aquifer in large numbers and starts consuming the compound, the pollutant. Once it's finished consuming the compound, then it dies off. There are thousands of sites contaminated with chloroform around the world, and this culture represents a realistic solution.